you guys see my screen too? Perfect, sounds good. Well, hello everyone, my name is Tito, and today I'm going to be giving a quick lightning talk on Swagger UI. So what is Swagger UI? Well, Swagger UI is an open source JavaScript library that helps API consumers explore and interact with an API. It provides live and up-to-date documentation showing controllers of the API and the endpoints within those controllers, and of course, their expected inputs and outputs of the endpoints. Within the tool, you can send real requests to any of the available endpoints within the API. And each endpoint's documentation provides a good description of it, any required inputs, and the expected responses. It also includes testing capabilities, allowing you to interact with and understand the API directly from the documentation. Swagger UI renders the documentation of the API via an interface directly in your browser. So when the API is running, the interface will also be rendering in the browser as well. You don't need any external tools like Postman, or you don't need to write any custom scripts, as you can explore and interact with the API entirely from this interface that's being rendered. Swagger UI is also agnostic when it comes to API framework compatibility. It could easily integrate with frameworks such as .NET, Node.js, Ruby on Rails, and many more frameworks. So before we talk a little bit more about the tool, I wanted to quickly go over some challenges with the API documentation and integration processes. When an API is live for consumers, they often have to go through and read through any written documentation to get an understanding of how to interact with the API. And that process takes time, and because the consumers need to search for the information they need, then they need to test the endpoints themselves, and then after verifying that everything is working as expected, they can finally start doing a final integration with their systems. This just delays the final integration process, as going through every single step is pretty time consuming. It's also time consuming during the development process. Developers not only need to build and maintain the API, but they also need to keep up-to-date written documentation whenever there are any changes made to the API, so the consumers know how to use the API correctly. This adds, again, extra effort and slows down the overall development process. Even after reviewing the documentation, consumers still need to be able to test the API in practice. Setting up scripts, setting up Postman requests, or using other tools to verify that the endpoints, again, takes extra time due to all the configuration needed and required to make live requests to it. As a result, integrating with the API can be a pretty slow and time-consuming process. So how Swagger UI helps? So in order for Swagger UI to do its magic, it takes an open API specification, which is just a standard format for documenting RESTful APIs. It uses that specification to render the documentation as live interactive interface in the browser. Developers can instantly view any available endpoints along with the up-to-date information about each one. If there's any changes made to an endpoint, and then the API is ran again, the documentation in the interface will automatically reflect those updates. This makes the documentation much more reliable and ensuring that the information is always current and never updated. Along with showing the current documentation of the API, it also gives developers the ability to send requests and see the actual responses in real time. You can try out the endpoints directly in the interface without switching to any external tools, like I stated earlier, like Postman. And also, you don't have to write any custom scripts as well in order to send requests to it. This makes it much quicker to understand how the API behaves. You can again try out any test data, any test inputs, and experiment with the endpoints safely before writing any code. In addition to live endpoint testing, Swagger UI also supports secure testing using authentication schemes such as bearer tokens or API keys. Through the interface, users can easily load in a bearer token or an API key, and once they load that in, any live requests that they make to any of the endpoints available will automatically include that token or key that they loaded in. This makes it extremely convenient and easy to test secure endpoints within the API safely and efficiently. So now it's time for a demo. Can you guys see this all right? All right, so this is thank you, Ed. So this is a test API from Swagger themselves, and they are rendering. Yeah, so as you can see, this is being loaded directly in my browser. I just go to that URL and I can see the Swagger interface. The top portion up here is just information about the API. As you can see, we can see the name of the API, a description of it, several resources that they have linked there. So it's just information in general about it. You can also see this authorize button right here. If I click this, I'm able to load in any API keys. And if this was a bearer token authentication scheme, it's just a bearer token. So I can load anything in right now. And once I click authorize and close, any request I make to any of these endpoints will include that token or key. On the bottom portion here, you can see information about the controllers available and defined in the API. Let me just expand the pet controller here. And these are the endpoints defined within the controller. As you can see, any of the icons that have the lock icon means that this endpoint is it's secure and it has to use the authentication scheme. And any ones that don't have it locked means that it is opened. You can just hit it without any authentication. So if you open up any one of these endpoints, you'll see more information about it. You'll be able to see information about the parameters it takes in. It gives you the request schema as well with some dummy values here. And in the bottom, it tells you what the response will be from this endpoint. You can try out these live. So if you click that try it out button, you'll get this little text box here where you could play around with any of the values. Again, this is just for testing purposes. And once you click execute, you'll be able to see the live response from the API. As you can see here, we get a live response, even though this is most likely just test data because it's a test API. But yeah, so you can see the live response. And that's pretty much it, really. Swagger UI, again, just helps you keep documentation over an API pretty up to date and always current, and allows you to make live requests that just play around with the API in a nice and safe way. So, thank you.
Great. Thank you, Tito. All right. So yeah, so as I mentioned, there's a thread in the Lightning Talks channel if you want to add questions or give kudos or generally chat about your experience using Swagger, if you have any questions for Tito. And yeah, so next up is Christina talking about To-Doist.
Awesome. Thank you very much. I'll go ahead and present to get started here. All right. Today, the topic I'm covering has to do with our tackling to-dos. And in particular, a tool that I have found very useful is called To-Doist. Now, the genesis for this, kind of idea was, I think when it comes to an individual project, we probably have a good way of already tracking action items when you're gathering with one particular group or team. But I wanted to look kind of broadly in the scenarios where we have multiple responsibilities, multiple teams, or departments or initiatives. And in the big picture, how do you handle these multiple to-dos across various different methods? For example, if you're a developer, the team that you work on might use a great tool like Jira to track, assignments. And those to-dos are kept in Jira. But what about to-dos that fall outside of it, like professional goals or to-dos that come up with in a one-on-one meeting, or even in your personal life with family responsibilities. And so what I really have found that Todoist is great at is kind of keeping all those things in one place, or having, kind of one place to track all those different aspects. In particular, let's see, in particular, some useful features are with Todoist are that you can organize tasks by specific projects. You can prioritize the tasks and assign due dates. This can also connect with your calendar. I use Google Calendar and it connects well there. And you can also add team members to projects and assign specific tasks to team members. So it works well in a collaborative kind of environment. Oops, sorry, too many. I'm gonna switch over to do a demo at this point and show you how it works. So the first thing I wanted to point out, Todoist is a free application. You can, there's both like a web version and a mobile app, as well as a desktop app. With the free version, you can create up to 5 unique dashboards. So that in itself is great. If you have different, if you want to separate your work by dashboards. I've created one sample dashboard here just to give you a look as to how it could be. And within that dashboard, you can create customized buckets, different categories of things that you're working on. So, in this regard, I put myself kind of in the shoes of a manager here at Solution Street, and I, made a bucket for business development. Let's say they're contributing on project A. They also have a project B that they're contributing on. Maybe they have tasks related to one-on-one meetings, as well as goals. And these are all kind of just made up for the purpose of this exercise. But you can add tasks to each of those categories, putting in a name, a description. You can also, using this one as an example, you can add due dates. For example, we'll add this one for next week on Monday. You can add a specific time for that. Let's say like 1:30 p.m., save. And then you can also assign priorities here. Priority 1, priority 2, priority 3, basically, escalating these tasks as needed, just depending on, how they are. I'll add a few other dates here just to show how it'll show up on the calendar as well. And there is a capability to filter, let's say you add a gazillion tasks, and now it's just a whole bunch of tasks there. There is a way to filter, and show, either by date or by priority or both, kind of what is needed there. And then I will just add a few more dates here for our example. Okay. Oops, sorry about that. Okay, so that's a good place to get started. I'm going to switch over to the calendar here just to show, let me refresh and go to next week. So here, this is my Google Calendar. These red what these red events are the tasks from Todoist. And even from my calendar, I could adjust this as needed. Like if I wanted it not necessarily to be at 1:30 p.m., I could always, drag it around, move it. And what's nice is this is not going to block out your actual Google Calendar. It's a separate like Todoist view for your calendar. So that way, if you don't want to actually clutter your other meetings, it doesn't have to be cluttered. But if I did want it to block it out, what I could do is edit this and just change from the Todoist calendar and actually put it to my own real work calendar there. But I'm not going to do that at this point. Great. And then I'll just switch back over to Todoist to show that there's like a filter feature here. Let's see. So sorry, I'm not able to easily find it at the moment, but there is a way to kind of organize these tasks where it shows the dates that they're due and the priority. So if you only wanted to look at high priority tasks, it would show that up for you as well. All in all, there's a lot of great ways to track to-dos, but I find this one to be really simple and effective. All right, that is all, and thank you so much.
Thank you, Christina. That was a great talk again. And yeah, you need to add a to-do to update Chrome. All right, next up is Ed talking about Java CLI apps.
Okay. Can everyone hear me now?
Yes.
Okay, let me just organize my screen here. Okay, hello everyone. My name is Ed, and I will be giving a lightning talk on JVM CLI, which is command line interface programs with GraalVM. And JVM is the Java virtual machine, for those maybe unfamiliar with those acronyms. I need to talk fast because I've got a bit of content here. So we're going to answer some questions first. Why would you choose the JVM? Well, your organization probably already has tons of lines of JVM code, probably Java, but maybe Scala. You can reuse all that. More importantly, you can reuse the vast amount of open source JVM code that already exists. And you get lots of language choices. So I specifically said JVM and not Java. So you can choose between Java, Kotlin, Groovy, Scala, Clojure. You can even choose between Java and Kotlin joint compilation or Java and Scala joint compilation. Joint compilation is not cross compilation. I don't have enough time to explain the difference, so Google it. All right, now why would you choose the GraalVM? Well, you could be just as cool as all the Go and Rust people and their native binaries. And more importantly, maybe, is if it's faster startup. So if you're not using GraalVM, you're not getting native binaries, and the JVM takes a long time to start up. And people expect instant feedback with CLI apps. There are, of course, gotchas. One major one, GraalVM, when it compiles code to optimize the binaries, it does static analysis, and it removes any methods that it determines aren't called with static analysis. Why is this important for the JVM? Because there are a lot of frameworks you would want to use that make calls only via reflection. And if calls are made only via reflection, GraalVM can't determine them to be reachable. However, there's an easy workaround. There are hints, and I will show that in the demo. And you should know that GraalVM ships with tons of hints out of the box. For example, for Spring Boot, for example. Okay, now I'm going to step up on my soapbox. So I have some very specific opinionated rules about command line interfaces. So any command line interface you write should follow these rules, in my opinion. First of all, your command line interface, your command line program should only output new line separated records. And again, I will say only records. It should not output headings to standard output, just records, nothing else. The primary offender here is Docker. When you run Docker PS and it outputs column headers, that annoys the crap out of me. So I will also point out that anyone who's ever used Java in this room does not believe that Java can achieve this. I will prove you wrong with the demo. These fields that are, of these records that are output, they need to be fields that are white space separated and no intra-field white space except in the last column. The reason for these rules is it just makes it easier to parse with tools like sed and awk and grep. Or if you don't want to follow these rules, just give me JSON and I will use JQ to format it however I want. So, okay, now the demo. Quick overview real quickly. Remember when I said you could use all of the existing Java code out there? I have aimed to do that with this simple CLI program. My tech stack is GraalVM, of course, and Java, also Scala with joint compilation, Pico CLI, which is the Java library I used for writing command line tools, Spring, H2, an actual embedded relational database, Liquibase, a complete database migration tool, and AspectJ, an aspect-oriented programming tool, all in this demo. So keep in mind that when I run this, every time I type this command, Spring has to be initialized, database migrations have to be determined whether or not they need to run, and at least one and sometimes two database connections are created in round trip. So get it in your head how long you think that that's going to take when I run this. So now for the, very quickly, when I run the demo, you'll see that the commands that run are actually run. This is just a script I wrote to make this easier for me to demo. The important line is 27 here. I'm just calling JVM CLI, which is the native binary that I've compiled with GraalVM. I'm just showing you this so that you know that I'm not doing any hand waving here and trying to trick you. Here is what these commands look like. So I wrote a couple commands. One is ls. This is written in Java. So you see Pico CLI allows you to annotate. This is the actual name of the command you'll type at the command line. You can put some metadata here that will be generated in the help that Pico CLI generates. Like I said, I also use Scala. So in Scala, I wrote a find command, which essentially doesn't do very much. It's as if you typed find dot at the Linux prompt. It just traverses directories and lists files. And then I also created a history command, show, which will list the history. And the important part here is this is a Scala class. It's having a Java class injected by Spring, which allows me to query the database. Remember I said there was a database. When I spoke about hints, here are a couple hints I had to give GraalVM because these methods are only called via reflection. And I said, hey, GraalVM, for this class, include all declared methods. Don't throw them out. And the same for this class. And queries we will come back to. So without further ado, I just wrote a make file to script this. So again, a little bit more magic. This is the script I'm going to run, scripts run -h, which will call my command with the -h flag. And I'm also timing it so that I can show you how quickly it runs. So I'm going to hit enter. Okay, so that took half a second. And now we got the help output that Pico CLI generated for me automatically. And so we see that there are two subcommands, filesys and history. Under filesys is where the list and find commands I created exist, and under history is that show command that I showed you. Okay, so now I'm going to run the ls command, but I'm only going to grab the first 10 results, which is what head 10 does here, so that it all stays on the screen. Okay, so that only took 0.3 of a second, and we see that we're just listing the commands in the local directory. Okay, now I'm going to run the find command. So this is going to look like the ls output, except it's going to traverse directories recursively. So now we see that I'm walking the directories. Again, this took 3.5 of a second, so about a third of a second. And now I'm going to show you what you expected to see, I think, if you're a Java programmer. So this -v switch, when I pass it to that run wrapper switch, this tells the wrapper switch to set some Spring configuration via environment variables. So again, this is an enterprise app, right? I can set enterprise command line app, trademark. So I can set Spring configuration values in the environment and it still sees them and listens to them. So what I'm asking it to do is turn debug logging on, and instead of logging it to a file, log it to standard output. So here we go. This is what everyone expected to see. Still only took less than half a second, but we have all this beautiful Java logging output. We got some exceptions in here. We got some Hibernate bootstrapping, you know, so this is everything that happens every time I run this app. And if you look really carefully, oh, don't blink, there it is. This is the actual output of the command. So of course you would never want to run it like this, but I'm just showing this because I think this is what people expected to see. They looked at this talk. Okay, so what happens when I give it garbage, right? Well, it tells me a very useful error message. Again, Pico CLI generated all this for me. So I said, run foobar fizzbuzz baz, and it's saying, I don't know what foobar fizzbuzz or baz are. And I think this is the last one. Yes, so now I'm going to run the history command. So when you look at this, this is the only important part. I'm running history show. All this garbage is just me jumping through some hoops so that I can show you the first 5 and the last 5 lines of output. Because I wanted to show you that it lists them all. So if you look at this, history only took 42 hundredths of a second. And you see that these are all the commands we were running in the demo, right? So foobar fizzbuzz baz, ls find, ls. And yes, so like I said, this is querying an actual embedded database. So to prove that to you, I'm going to come up here and I actually have a query. I can connect to the same database. So here we see there are 371 commands. If I run a count of that table in the database, I see 371 over here. Furthermore, if I run this command where I select from the command invocation table and left join to the command argument table, we're going to see the actual query that I run to generate this output. And if we scroll all the way down here, we see 371 rows. I call JVM CLI because remember, that's the name of my program that the run script wraps, and the history and show commands. So almost done. One last thing here. So this database I keep talking about, where is it? Well, every time you run this command in your home directory, if it doesn't exist already, it creates this JVM CLI directory. So what's in there? Well, there's a database and a logs. If we look at the database, this is all managed by H2. So here is my file system database that manages all this stuff. Again, every time I start this command, if I have a migration, it will run that migration against the database. And if I look at the logs directory, I have a complete rolling log solution where it compresses all the logs and rolls them for me. Because remember, this is just Spring. And if you miss all that Java output, you can come here and look at it in the log. I've got about 17,000 lines of it. This one's probably due to roll pretty soon. And that is just about it. So in summary, GraalVM, you get the entire Java ecosystem, you get a single binary, and you get fast startup. That is it for me.
All right, amazing. Thanks, Ed. I see you're repping Todd Barry. Did you go see him sometime or?
I did. Arlington Cinema Draft House. Yep.
Oh, cool. I love that venue. That's a pretty fun venue. Very cool. All right. So yeah, batting cleanup, I guess, is Jeff with Monty Hall game. That looks like a fun one. Yeah.
Awesome. Can everybody see my screen? All right. So this is not the Monty Hall game. This is the Monty Python movie. And now for something completely different, because this will be very different from Ed's talk. If I can figure out how to get to my next, okay. Move all you guys out of the way. Okay, this is the Monty Hall game, or fun with probabilities. This is one of my favorite probability related questions / games. So I'm going to share with everyone. Hopefully I'll blow your mind. Okay, so here's the setup. You're a contestant and you're on a game show. And the iconic host of the game show, his name is Monty Hall. He presents you with 3 doors. The door placed randomly behind the doors, there are 2 goats, and the third hides a brand new car. So of course, Monty asks you to pick a door. You pick a door. You say it's door number 1. What happens next? Monty now opens one of the other 2 doors to reveal a goat. So now there's only 2 doors left, door 1 and door 2. What does Monty do next? He says, here's your option. You can switch to door number 2, or you can stay on your door number 1. So I'm going to pause here for a second. Everybody think about, what are the chances of winning if you stay with your door number 1 or if you switch to door number 2? Pause, just think it through. Nobody has to, you don't have to answer, just think. Okay. Now, given that Monty knows where the prize is, that's important. He knows where the prize is when you start. Should you switch? What are the chances of winning if you switch? What are the chances of winning if you stick with your original selection? It's a very counterintuitive question. Should you switch? The answer is yes. Every time. Every time you should switch. Your chances of winning if you switch are 2 and 3, or 66.67%. And your chances of winning if you stick with your original selection is only 1/3. What kind of voodoo math magic is this? Why isn't it just 50-50? There's only 2 doors. Okay, so let's explain it, because this is a very fun game. This was first posited by Marilyn Voss Savant, if that name means anything to anybody, in Parade magazine back in 1990. She showed that same setup. She revealed the probabilities. The response was over 10,000 letters complaining, including one letter that was signed by 1,000 PhDs of mathematics saying she was wrong. Okay, but she was not wrong. Your chances of winning are 1/3 when you make your initial door selection. I think we can all agree on that. You only got a 1/3 chance picking the right door. When Monty reveals the door that has a goat, he doesn't give you any new information. He knows where the prize is. He can always reveal a door with a goat. When you switch to the remaining door, it ups your probability of winning to 2/3, as you effectively get the probabilities of picking 2 doors from the start. So let's do a thought exercise to solidify this in everybody's mind. You pick door number 1 initially. Now there's only 3 scenarios. Door 1 contains the car, door 2 contains the car, and door 3 contains the car. Let's say door 1 contains the car. You picked it right off the bat. Well, Monty will reveal, let's say door 2 as the goat, and you follow Jeff's advice and you switch to door number 3 and you lose. You should have stayed on door number 1. But let's look at the other 2 scenarios. If door 2 contained the car from the beginning, then door 3 will be revealed as the goat from Monty, and you should switch to door number 2. You stay on door 1, you're going to lose. If door 3 contained the car, then door 2 would be revealed as a goat, and switching to door 2 would get you the win. Therefore, 3 scenarios where door 1 contained where you picked door 1, 2 of them you won, 1 of them you lost, 2 out of 3 for the probabilities. Now, you can play the game yourself. I've actually created the game. There's a bunch online, but you can use mine. And I'll put the link I'll show the link, I'll show the game in a minute, but you can use and play the game manually on my website. And there's actually a simulator there where you can simulate playing it 10 times, 100 times with different strategies. Okay. And we'll show you that in 1 second. There's a good description of the game and the probabilities. Why is it so hard for humans to understand this? And it's also where I got the helpful pictures. This link will stay in my presentation for you to look at later. But let's look at my game that I came up with. So here's the website I created, and let's play the game. So let's pick card number 1. You click on card 1, and Monty has revealed the goat. I'm going to switch. I like that strategy. Hey, I won. That's awesome. So on this site, if you play the game, it will know what strategy you selected, and it will tell you your win strategy when you pick. So let's play the game again, and let's try just taking the same strategy each time. Oh, sorry. I'm going to switch to my other card. Hey, I won again. Let's try again. Look at this. I keep winning by switching. I should always switch. And let's see. I'm trying to lose. I lost. So 75%. Now, here's the autoplay piece. Let's reset the stats. And let's stick with our switch strategy. And let's play it just 10 times. When you click begin, it will kind of do the magic of showing it playing. And you can see the switch win rate over here with 10 games. Not too good, is it? Only won 30% of the time. Small enough numbers that these kind of things can happen. But let's go to 1,000 games. I sped it up when it plays 1,000 games. So we kind of, unless you're, I don't know, the Flash, you can't really see what's going on. But look at where the win rate is hovering around. This is when you use large numbers, you'll start to see over time, it's going to more conform to the actual probabilities. So I'll put this, the website address here into our Google Chat space. Everybody else can play around with it. This is a fun game. One of the fun memories I have of my dad was me trying to explain this to him. It probably took me 30, 45 minutes to actually explain this to him. He just had a hard time getting it. I had to break out like a deck of cards and play with 52 doors. And that's finally got him to understand it. So I hope you enjoyed hearing about the problem. It's fun to share with family and friends, and you'll very often find people who just will not be able to sort of comprehend and believe you, and they'll say it's 50-50, but that's not what it is. It's 2/3, 1/3. So hope you enjoyed my talk.
Right. So yeah, again, round of applause for all our presenters. Thanks a lot for great talks. And yeah, Jeff, I did enjoy it. I obviously thought it was, on the surface, it looks like it should be even, but yeah, but you explained it and I'm convinced, I guess. So thank you so much. And thanks again, Tito, Christina, and Ed. This was really great. And again, we do these every couple months. We have a sign up page. I will plug it again in the general chat room, add some topics there. And then once we collect a few and we have a date, we'll do it again. Thanks, everybody.